Alright, so we're going to get cracking with this little tour of ours. And if you get a chance, you can take a peek inside the decontam, see if you can shoot it through the window. Alright. Okay, good. So, what do we have? We start off our trip through the decontamination area, and though we can't go in, we'll talk about it. First things first. Cleaning is the most important step in the entire sterilization process. If you remember, cleaning is the removal of all gross visible and invisible soil. Okay? We do this with a manual and an automatic process. The main tool for cleaning, if you recall, is water. Okay? Before we get to anything else, we have to discuss what water is. Water is also known as a wetting agent, if you recall. Do you recall?
Yes.
Okay. So water is the wetting agent. Water has to be pure. So for purification process, we use reverse osmosis deionization process. Reverse osmosis uses special membranes to filter out all other impurities except the H2O, which is pure water. The deionization process removes electrically charged particles known as ions. We want to get rid of the electrically charged particles known as ions because they stain and corrode instruments. So that's why we remove them. Everything starts off here with a 3-sink setup, okay? Soak, wash, and rinse, just like in every restaurant, okay? We brush our instruments with nylon brushes made out of soft nylon, which can be reusable or disposable brushes, right? Or we use impregnated sponges. Sponges are impregnated with enzymatic detergent, and we use it, once again, underwater to prevent the aerosolization or the spray. If you recall, the word aerosolization literally means spray. So we do it in a to and fro motion, or back and forth, not against the grain, but with the grain, never in a circular motion, okay? And once again, going back to the water, how do we test water purity? Well, we do it through conductivity. Pure water does not conduct electricity, and so we use a special device called TDS meter, or total dissolved solid meter, to measure the water purity. If the water is pure, it will not conduct. The dirtier the water, the more it will conduct. The dirtiness of water, or visual dirtiness of water, is called turbidity. The most common impurity in the water is silicate, or sand. We use detergents in this particular section. We do not use soap because soap leaves residue. Detergents do not. They also contain enzymes. Enzymes are catalysts that promote digestion, or the breakdown of various nutrients, if you will. And since we're made out of nutrients, we're made out of protein, fat, and carbohydrates. We use special enzymes known as protease, lipase, and amylase. Protease digests protein, lipase digests fat, and amylase digests carbohydrates. Okay, very good. So we use these detergents. Detergents are some things that potentiate cleaning, okay? Detergents have to be low foaming, right? Free rinsing, correct? They have to have a pretty long shelf life, all right? And they have to be, what was that thing? Cost effective, yeah, cheap, right? Or as cheap as possible. As we know, nothing in the hospital is cheap. The most common thing that we could, that could hurt us in this particular section is a water spill in the floor. So we can slip and fall, and that could potentially cause a work-related musculoskeletal disorder, or WMSD. Right? If you peek inside once again, you will see a gentleman, and I assume that this is a gentleman in there, and look at the amount of personal protective equipment, or PPE, that he's wearing. Okay, so he's wearing spill-proof and leak-proof garments. He's wearing goggles, a face mask, headgear, and special booties on his legs and feet to prevent aerosolized water, or just water, contaminated water splashing him. Okay. This is mandated by OSHA, or Occupational Safety and Health Administration, that mandates employee safety. Okay, we also deal with FDA, Food and Drug Administration, DOT, Department of Transportation, and the EPA, Environmental Protection Agency. All these government agencies that oversee what we do here in the Sterile Processing Department, making our life more expensive here. Okay, so in the decontamination area, once we're done manually cleaning our tools, we go for mechanical cleaning, okay, towards the process of disinfection and decontamination. When mechanical decontamination process is finished, the instruments are safe to handle with their hands. But not with your hands, rather, not their hands. Instruments don't have hands, correct? Okay, so safe to handle. What is decontamination and disinfection then? Decontamination and disinfection is the process of the destruction of most microorganisms. And this is the second step in the sterilization process, where sterilization is the destruction of all microorganisms. The mechanical disinfection process begins with a device called Ultrasonic Cleaner. Ultrasonic Cleaner, that's where that little bubbly water is, okay, uses the process called cavitation, or the formation of tiny bubbles that implode around the instrument. The implosion creates a little vacuum around the instrument, effectively sucking off the soil particles off of the instrument. Once the cavitation or ultrasonic wash cycle is complete, what happens is that we move on to our next step right over here. And this next step is the final piece of the mechanical washing process, or the final piece to the decontamination process, and that's the mechanical washer. So let's walk over this way, we'll take a look. There's some cycles going on there. So if we take a peek over here, we have a machine that actually goes from the decontamination side to the clean side, okay? On the decontamination side, as you can see so far, you know, when one side is open, the other side is closed. The air circulation between the two sections do not interconnect. So before I explain to you about the mechanical washer, and as you can see, it's just your, I don't want to say run-of-the-mill dishwasher like you do at home, but it's very similar. It uses high pressure water and high temperature, and the process called impingement to knock out, and the word impingement means to knock out dirt particles, and when it comes out, it's literally decontaminated or disinfected or safe to handle with bare hands. So before we go on from here, let me just explain to you about the environmental concerns on the other side, okay? Everything we do here has to stun the growth of bacteria and other pathogens. And what pathogens do we remember? We remember bacteria, viruses, spores, right? Fungi, and prions. Prions being those little microorganisms that cause a disease called CJD, or Creutzfeldt-Jakob disease, which is a brain and nervous system disorder, degenerative disorder. It kills, there's no protection against it. It's an interesting thing. Okay, but that's all we need to know for the exam. On the other side, we have negative air pressure, and to prevent bacterial growth, temperature there has to be cooler. It has to be less humid, okay, and lighting has to be very bright, because bacteria likes wet, warm, and dark places. Not just bacteria, but all microorganisms or pathogens, as we know them, okay? Well, briefly about bacteria and viruses, if you recall from our class, bacteria are living creatures like cells that move, right? They need a tail, or little legs, cilia they're called, right? To move around. They like to move around in water. That's why they like wet, warm, and dark places. Wet is for movement, warm and dark for reproduction. Okay? So the difference between them and viruses is that though bacteria is a living organism, if you remember, living, of course, is defined as something that eats, is breathing, able to reproduce, make waste, and die. All other things are not living. So virus is not living. So bacteria is living, virus is not living. Viruses are also 1,000 times smaller. Okay, so it's much easier to acquire a viral infection, if you will. Viruses, though, they don't move on their own, and they require what they call a vector, something that carries a virus from one entity to another. Okay, so think back to your chain of infection, thing that we discussed between a sick person and not yet sick person. You know, the reservoir of infection, a portal of exit, mode of transmission, portal of entry, and then of course a susceptible host. You can check your notes later to see what these things all mean. But now we're back to this particular area here. Hit the stop button for a second and resume.